I'm the old engineer now. I'm the old dog now, right? And now I'm being asked to write code in a way that challenges, like, I'm like, no, I want to use my text editor. Or in my case, I'm like, I want to write my own code. If you wake up and you put on a nice suit and you look good today, go build a deep fake of yourself. We've got this hammer, GenAI, and everything's become a nail where we're just like, bam, bam, bam. Baby tigers are running wild. Like, and then they don't even have an inventory of AI systems.
It won't crash like a software. It will fail.
Right? Agents can go from declarative, which is when you describe its behavior and human in the loop, to autonomous in a click of a button. And it's so tempting.
Rightly.
Left and look right. And everyone you just looked at will be either sued or will sue someone in the age of AI.
What is the line you see between the responsible agent and a dangerous one?
I always say I'm drinking my own champagne. I'm using AI as I'm building an AI company.
This is the Spark and the Coach podcast. I'm Subrata Kar. My guest today is Noelle Russell, CEO of the AI Leadership Institute, and one of the most experienced AI practitioners in the industry. She built AI systems at Amazon Alexa, Microsoft, IBM, and Accenture. And she has been doing this since 2014, before most companies even knew they needed an AI strategy. In this conversation, she breaks down exactly what's breaking and what's organization that get it right are doing differently. So if you are building AI inside an enterprise right now, this is the conversation.
I have a couple different ways I think about that, right? Like I actually do think that many of our challenges today it stems from a leadership challenge, not necessarily a technical one. So the challenge is really twofold, right? One, how do you get leadership to embrace that we can think differently about the way we do things now? And this is 10 years ago. I think it's even more true today. But also, how do you get the people you're building for to think differently, right? To really break outside of the mold that we've all been in for 40 years of how we work and how we collaborate with technology. All of that is evolving, I think, at an incredibly, not just a fast pace, but it's really it's more of a mindset shift than it is a technical one. We have plenty of capability right now in our technology, but do we have the leadership that can harness that into business value?
So that's uncomfortable because most teams, when something fails, immediately go to the model, tune it, fine tune it, add data to it. But if the issue starts at the leadership layer, then the debugging is happening too late, which means by the time it shows up as a technical issue, it's already baked in. So I wanted to understand that better. When pilots fail in production, what actually breaks first?
Oftentimes, the main reason why AI systems fail to ever reach any level of value in production is not because of a technical failure, but actually because of an adoption failure. And one of the most staggering statistics out of this study was that the people we were building for were actually resistant to using the technology. So much of those failures happen out of sheer executive misalignment, but also human adoption. People were just like, I'm not using it. What happens in a world if I don't use your AI? We are not at a point where AGI is replacing humans right now. We are at a critical moment where we need humans to guide those machines and tell them what good looks like. Now, on the other side, I think you probably would be interested in is on the technical failure. Like what happens the day I move past, in my book, I use an analogy of a baby tiger. And that every time you adopt a new model, it's like a baby tiger, right? People are like, it's so cute and I love it. Look, it does meeting notes and oh my gosh, it can generate action items. But one thing often happens is that once that little baby model starts growing up, there are certain things that begin to happen. And I've identified 3 classic problems that companies fall into. One, and I call it SAT or SAT. One is security, overprivilege, right? These models tend to not have a very secure, even like all the lessons we've learned from cybersecurity. We have not implemented these for our AI systems. For whatever reason, it kind of loops back to the first one, which is trust. The only way most of these systems, even if they're secure and accurate, if it doesn't garner trust with the user that's using them, those systems tend to fail. And trust ends up being, like we had mentioned briefly before we got started, trust is actually an engineering effort. It's something that we have to weave into the DNA of how our systems work. And there's lots of different frameworks we'll talk about maybe throughout the
Yeah,
session, our conversation.
sure. What stayed with me wasn't just the adoption resistance, it was the idea that the trust isn't soft. You don't declare it, you build it into the system. Security posture, accuracy discipline, clear boundaries. And these aren't just add ons. So the question becomes, who's thinking about those early enough? Because they don't appear magically when you ship.
I think it's a really important perspective for organizations to take, because AI, granted, this is, over a decade in the making. But one of the early lessons I learned speaking to executives at Amazon was that these decisions do start in the boardroom. So that's how I positioned it, right? Like, it starts in the boardroom. Those boardroom discussions, those boardroom decisions are what are going to equip you with the funding, the resources, the humans they're going to help you build. And so it's really important to get their engagement and, most importantly, their buy-in first. It's one of the things, so one of my specialties is AI solution architecture. I love the role of a solution architect, a technical solution architect. We're typically the glue that holds it all together, right? We understand engineering, but we also understand business value, and we bring our boardrooms along. But the most important thing you can do as an AI solution architect is be someone who's a doer, not a talker, right? Who shows more than they tell. So in these boardroom discussions, we're now able to demonstrate, like, in the boardroom, we can demonstrate the value that they're going to see later. Most organizations are still kind of 2002, where they're thinking, I'm going to just describe what I can do for you and then hope that we get there over time. But we're in a new world now, right? So that boardroom really needs to see the system, see the prototype, what I call a minimum remarkable product, right? Like, it's an actual deliverable that is working, but it's minimum. It's not the whole thing. We're not boiling the ocean. It's something pretty small. The very next person that I need to make sure is on board is the technical architects, right? Is the senior technical leadership. And that's what I frame as the whiteboard people, right? The people that are in there whiteboarding out the problem, making sure that we've thought of it from every angle. And this goes back to how you introduced us this at the beginning, right? Is when we get those people together, we're looking for people in the room. They're going to ask different questions, right? We need to invite people into the whiteboard session that are usually the last people we call, right?
Yep.
Security, legal, DevSecOps, like people that usually are the ones at the end going, oh, wow, I wish you would have come to me. But we invite them earlier because their insight helps us build software that serves everybody.
Board, whiteboard, keyboard, it sounds neat. But in reality, those conversations rarely happen at the same depth at the same time. Funding decisions get made fast, architectural conversations get compressed, and delivery teams invariably inherit whatever assumptions were made upstream. And if that chain isn't tight, problems compound quietly, which makes the 5% more interesting because they are clearly doing something structurally different.
95% of pilots are failing to ever reach production. But the 5% that are examples of this process, that have executive buy-in, executive sponsorship, have invested in their whiteboard people, their senior technical leadership to design a new way to work. And then finally, they've actually invested in educating their employees and giving their employees a fighting chance to collaborate with these technologies to create a better outcome. One, their leadership team thinks differently. So they're adopting this ARC framework, right? They're investing in creating awareness, not just in the technical teams, but across the entire organization. And they're building competitive advantage by activating, that we're talking about procurement, supply chain, like people who normally don't get any tech love. Like making sure the whole organization has it. But one thing that's very different, and I learned this actually, I was a keynote at the RSA conference, right? The security conference that happens every year. I was the keynote, and I happened to have on stage with me was like the CISO of Anthropic and the CISO of Meta. And they were talking about what they were worried about. And they're the 5%ers, right? These are people who've built production frontier models, have millions of users. And what they're doing differently, and even Zoom, right? So Zoom was also part of one of the panels. And what they're doing differently is how they see the world of agentic or autonomous AI evolving. And one thing that they had identified that I personally immediately, this was last year, immediately started doing is that the 5% recognize that there is a layered approach to building out this technology. The first layer is that when you build it, you cannot overprivilege these systems. So of course I'm in a security conference, but most people building AI systems have not really even thought about the boundaries in which these AI systems should operate. And here was a unique thing that Microsoft had shared was, if you know a little bit about Microsoft's environment, if you've ever talked to a vendor of Microsoft, you would notice that all the human vendors are given a separate domain that called V dash vendor dash, right? So if you get an email from someone that says V dash, they're a vendor. Like they're working with Microsoft, they've been given a Microsoft domain, but immediately that they're a vendor. And so we had a conversation about like when you build an AI system, when you start building a fleet of agents, the first thing you're going to do is put them in a box that lets people immediately identify that they're talking to an AI. A dash, AI dash, agent dash, whatever you want to call it, right? But that agent force, right, that Salesforce is so proud of, it has to be uniquely identifiable. And when you do that, not just for identity purposes, but now inside that domain, I can manage role-based access control. I can identify what you get access to, what you don't get access to, and I have a kill switch to kill the entire thing, right? Because they're in this protected domain. So that is something that most organizations aren't even thinking about until their baby tigers are running wild. And then they don't even have an inventory of AI systems. The other thing, so that's an overprivilege, what we call creating a minimum, right? It's a principle, right, of minimizing the access that an AI system has available. The other thing that I'll mention that's part of the 5% and what they do differently is that they also, when they build small. They build very iteratively. And this requires a lot of discipline. And I've been in rooms with, very big companies, life science organizations, billion, trillion dollar valuated companies. And when I'm talking to them, they struggle to build a single remarkable thing and get it working before they're like, let's just light it on fire and let it go. And I'm like, no, we can't boil the ocean. With AI, you really need to get those atomic units of work operating extremely efficiently with human oversight before you actually let it into the world to work autonomously. There's a method to the madness, right? Like there is a process you go to. We call it the machine learning life cycle. It's just like, for those of you, if you're in software engineering, like SDLC, well, there's a machine learning development life cycle as well. And it's very different because the models learn on their own, right? They are gaining their own level of awareness. So another thing that these organizations do is once they get into production, they develop what's called an AI red team that monitors accuracy, security, trust, right? They're constantly monitoring the behavior of their model. And most organizations, they think it's like software. They just build it and put it out there. And I'm like, nah, be careful.
What I hear, there is intention around risk. They don't just build something and hope it behaves. They decide early how much authority it gets, what it can see, and how far it can act. And that changes the exposure entirely. And it becomes even more important once you realize that we have been casually using the word AI to mean very different kind of system.
One of the machine learning concepts, and I know you mentioned like this difference between AI and GenAI. I think I kind of consider it a big AI umbrella, and that there are multiple AI systems underneath. Microsoft terms this as a AI workload, right? There are different types of workloads. Some workloads do not require, and I would encourage you to think very carefully about, does your solution require generative models? We built and launched cognitive services. Those are all now called AI services. We have computer vision, document intelligence, natural language processing, semantic search, none of which need a generative model that has these challenges that you're talking about, right? When you move to generative, it has its place, but I'm not sure it has its place in any environment where I require accuracy, right? or consistency. One of the opportunities we have, and I think most people, once you dive into the architecture, like the transformer architecture, or these newer architectures that we're building that manage memory, that is the key, right? Is memory management with these generative models. And there is a way now to build models architecturally that don't lie. The challenge is that it's engineered. It's not by default. And so when we engineer that or architect that, what that means is that we really need to think about this term cognitive memory. So there are models that are deterministic. And if you can use them, I hope you do. As a matter of fact, every solution you have should be a collection of Lego blocks, like just like a deep learning model, right? Like what exact problem and what part of the problem can I solve? And then solve it with the simplest architecture possible. And then you'll stream those together and eventually create an AI workflow, but it should not be one Gen AI model to solve them all, right? It should be maybe maybe if I'm an insurance company and I'm taking in insurance claims, I'm using, a forms recognition, document intelligence tool that is deterministic, that has 100% accuracy on reading information from a form. Then that passes information, right? Maybe I provide feedback through an LLM, but the actual documentation itself is going to be pretty deterministic. I want to know, did I get your name right? Right? Did I get your social security number right? Did I get your loan information correct? So I think it's a blend of all of the different types of AI workloads that are available, and understanding it's a wide collection from, like I said, natural language, document intelligence, computer vision, object detection, right? Like there's so many anomaly detection. There's so many different types of technologies. It's really in our best interest not to become, an expert in all of them, but at least, I call it like a Jill of all clouds, like jack of all trades. Like you should have we call it a wide, breadth of understanding of all the different types of models. And Gen AI is just one little one kind of at the end. And I kind of see it as it's an amazing opportunity to create a conversational user interface for anything you're doing, but it is not the model that holds the truth. It's not the model that preserves, right, the integrity of your application and the value that you're driving. It just provides a way of creating a human interface for your system. And I think we have, I always make a joke, like we've got this hammer, Gen AI, and everything's become a nail where we're just like bam, 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 bam.
Yeah.
And not everything needs generative AI. It really does need to be architected. And so I empower you to let's think about being architects instead of just picking the first tool that comes to mind.
That distinction matters. A generative model and a deterministic systems don't behave the same way. So if you let variability sit in the wrong place in your architecture, then you introduce instability where you need precision, which means the product design isn't just about features. It's about deciding where uncertainty is acceptable and where it isn't. And that's where our idea of minimum remarkable product becomes interesting.
Yeah, absolutely. Like I think a lot of people tend to think very traditionally when it comes to building your first AI project. MVP, minimum viable product, is an easy place to go. It's the path of least resistance. However, in today's day and age where we have vibe coding solutions, anyone can build a viable product. Like Viability doesn't sell a board. Viability does not get people in your company excited about AI. It's all about identifying remarkableness. And this in and of itself is a bit of a challenge for most organizations because it requires you to have empathy for the people you're building for. Do you know what they think would be remarkable? It requires you to learn about your audience, learn about the customer, the client, learn about your employee. What would make them go, oh my gosh, this is amazing? And I'll give you a quick example. In the early days of Amazon Alexa, we were building a voice system. We wanted big brands, big banks to leverage it. We wanted you to be able to just have a conversation about your finances in your home. And we really had to find a way to get the banking industry to be like, okay, we want to do this. They didn't need another technology. They were already quite busy. So we wanted to find a remarkable solution. So here's what we did. And I encourage you to use the same program process in your own company. This is like website analytics. However, you could do the same thing by watching your employees and being like, what are the things they do every single day? And what are the things that take them the most time? That is where you start. You build one feature that reduces the time to do something that they do every single day. The benefit of this is twofold. One, it's creating instant productivity, right? So you're cutting time, which is value. But the other thing is that someone, like the person you're giving this AI system to, is going to be like, oh my gosh, I used to spend an hour or even 10 minutes doing that. Now it takes seconds. It's instantly remarkable because time is our most non-renewable resource, right? So when you give someone back their time, not as a full-scale production system, like it's not all about time, but in the beginning, that remarkableness is almost always giving back someone a renewable resource or a non-renewable resource they can't get back. Once those minutes are gone, they're gone forever. So you then go back and say, oh my gosh, I can give you. So I have a product that I deliver now. It's 6 different agents. And these agents are like a receptionist, an executive assistant, a social media manager, a legal assistant that just give me time. And at this point in the month, it saved me from February 1st to now. It has saved me 430 hours of my time. Like every day, I'm like, I like you all so much. My little agents, you are my favorite, right? And it's just the beginning. But this is how I think remarkableness shows up is how can you provide immediate value to the person that you're demonstrating to, as opposed to getting lost in the weeds of building something so big that people lose excitement over time.
That distinction matters to me. Most teams ask, can we build this? And the better question is, will anyone actually use it? Because a system nobody uses isn't a product, it's a project. And here is what I find interesting about Noelle. She doesn't just advise on this. She does it herself.
You created something, a deep fake of yourself. What are these? Why did you create it?
Great.
What are you
Yeah, I
trying to
love this.
experiment?
Yeah, 100%. So I use a platform called HeyGen, and I love this platform. I've been working with them for years. I was an early design partner, got an opportunity. So my first deepfakes were not awesome. They were good, but not great. My second level in like 2022, 23 timeframe, they started to get very good. 24, I think, was my favorite. I'm still using that one in my keynotes to this day. But the reason I built them is a couple of different options. One, I'm on social all the time. And so being able to weave in Noelle, I call it nearly Noelle. So I have about 32 nearly Noelles. And I can weave those in to social media without me having to sit in front of a camera. Now, granted, I did sit in front of a camera to make the deep fake, right? So I sat there, but I spent 2 minutes in front of my camera. And I always tell people, if you wake up and you put on a nice suit and you feel like you look good today, go build a deep fake of yourself, capture yourself in that vibe right now so you can reproduce it. Use cases, training, sending information out to your team. It's so much more engaging, and you don't have to fake like it's you. Literally be like, this is what I say. Nearly Noelle is here to talk to you about a new topic, right? People right now, I think there's a little bit of chemicalization that's happening in the industry around, is it AI? Is it not AI? Soon everything will be AI. It won't have this uniqueness. The only thing you'll get is your time back. And that will become your most valuable asset, is that you are not sitting in a recording studio for 3 days in a week to record content that you're going to use on social. Now you're going to spend 2 minutes, create a deep fake of you in a bunch of different outfits and different personas, different locations. And you'll be able to use those, not for the pillar pieces of content, not for the most important conversations with your clients, but for all the little things. I use it for training. I use it for introducing me on a stage. I use it for advertising my new products and services. I like it to be me, but I'm also extremely transparent that it's nearly me. And it actually helps people understand that I always say I'm drinking my own champagne. I'm using AI as I'm building an AI company. And so I think it's unique, and it's certainly worth trying. Even if you never go to production with it, it's worth seeing what process is necessary for a deep learning, like a GAN, a general adversarial network, a convolutional network to create something that looks like you.
That's the thing about Noelle. She is not describing a theory, she's showing you her screen, and which is exactly what she will tell you to look for in anyone else. Now, one more thing that she said that I haven't been able to shake. Most organizations think they're aiming high. They are not.
Absolutely. Oh my gosh. I love this conversation I had with the leadership at Palo Alto. They're one of my favorite clients. And one of the things that I have uncovered, and again, this is just after a decade of talking to executives, and I'll even use a term, industry standard, right? So this is how I can see it in a company, is that they are listing industry standards as like the bar for excellence. And even some of you listening might be like, wait, isn't that the bar? And what I always say is that these standards, it's just like government regulation. Like, that's not the top of what we can do. That's the bottom of what we can do, right? Like, that's the bare minimum of what we can do. And today, especially when we can partner with an AI system as a thought partner, as a strategic thought partner, there is no reason, like, industry standards become the bare minimum. Everyone has to do that. How do you differentiate yourself in the world of AI, right? How do you differentiate yourself in your industry? You do that by thinking way above what the standard is, right? Way above where everyone else is, way above what you did last year. It is, and it requires you to have, again, this leadership principle. So I have a set of leadership principles. It's called the lamplighter effect. There's even a podcast if you want to go listen to all the principles. But like in this, it's an acronym, lamplighters. I won't go through all of them. That's a lot, but they're my personal leadership principles. But the first four is like being, of course, leading with love. That's Noelle's vibe. But also being ambitious, being mindful, being purpose driven. But way down there in the I is imagination, is having creativity and imagination. I'm an engineer. No one's ever really called me to be imaginative, right? I'm scientific in my approach, but there is an art to the science.
But imagination doesn't pay the bill. So I asked her, what does it actually return? You see, IDC found companies investing in AI are seeing $3.70 back for every dollar spent. Top performers hitting around $10. But 95% of the pilots never get there. And the gap isn't the technology. It is whether you built it right from day zero.
I do like the idea that you are kind of you're the artist pulling these things together. You are creating something in your organization when you build AI systems. This is different than building software that you can just say, here's what I want, and some engineering team builds it and lobs it back. This is a very intricate and interwoven set. I call it a high matrix of skills that are required for successful AI projects. And Poet, it has 4 different steps or 4 different parts of it. But the first one I think is so important, which is precision, is that we now have an opportunity to just use the data we've collected, right? I spent, in 2000. So, but good news, we have enough data scientists that we're willing to build AI systems that could do data science work for us, right? So that is the evolution of thought, is that you already did the work. You've already been saving a lot of your data into the cloud, all of your server data for sure. But we've got a bunch of data about how our customers work, our CRMs, right? Many of us have segmented populations for the people we work with. We have our employee data. All of this data now can be used with a level of precision to solve problems in ways. And again, this is bringing back the backlog, right? Going back and solving the original problem we wanted to solve. Not with all of the, I had to sacrifice this because I'm using this ERP and that ERP doesn't understand this data structure. We made all these, we call it tech debt, right? We made all these sacrifices along the way because the technology couldn't meet our needs. But now we can vibe code an entire architecture, right? We can use our words to describe, here's my problem, how can I solve it? And these models like Hero or, GitHub Copilot, Claude Code, they have the benefit of trillions of lines of code that have been written and hosted. They can look at all the ways people have been successful and failed and help you write software that is better. Now, granted, you still need, I personally think right now, I like to, as a human engineer, review it. Maybe I would refactor it in a different way. But most organizations, i.e. Microsoft, Amazon, Salesforce, they've completely delegated certain SWE tasks, software engineering. Certain SWE tasks are completely delegated to AI. And let's face it, if you're a SWE, if you are a software engineer, there are things you don't want to do. So you're not even sad to let it go. You're like, please do that for me. Please write my documentation. Please create my GitHub README docs. We're giving that stuff away. So I think that is a really, that precision unlocks this new opportunity for us to optimize our workforce, right? For us to optimize the way we do business. And of course, it sits on an ethical foundation. And I always say the underpinning of every AI system, no matter how cool the tech is, if people do not trust you as a company, you as a leader, you as an engineering, like the asset you built, if they don't trust that technology, they're never going to use it. Just look at Google Lens or the Fire Phone at Amazon. Amazing tech. I still have it in my drawer. Amazing. But nobody bought it. Nobody used it. So if you can't get adoption, it doesn't matter how good your tech is. And that's why it's leaders plus tech that work together. And finally, I'll give you an example. The
Yeah.
human resources part of organizations are really changing, right? So companies like Boston Consulting Group, they're combining HR and technology. HR is no longer, some of you might know in like big companies, like when you hear HR, you're like, oh, why are they here? Like they're here to like, hurt people. But HR in general is really understanding human capability in the company. And now in the age of AI, they're going to understand what the humans can do. So the AI you build amplifies those humans. Those are the 5%, right? Those are the ones who are winning with AI, are the ones that are taking the humans they have and amplifying their capability, amplifying their ingenuity, amplifying their, their ideas so that they can do more with less. And that I think is what most people don't really realize, is that AI is not taking those jobs. AI is amplifying humans.
So the ROI is real. But here is what I keep seeing. You see, most organizations think responsible AI means policy document or a committee or a workshop. It doesn't. And Noel was very direct about this.
I definitely think there's the challenge in our industry because of the siloed way we've developed our organizations, right? Even in the executive suite, there's the CTO, the CIO, the CEO, and they're often considered kind of in their own lanes, right? You handle tech, I handle vision and strategy. And in the world of AI, like those relationships are combining, right? So, as a technical founder, it is going to be very advantageous to you to be, of course, a strategic thinker, as well as understand the technology that's available to you to build out that strategy. And I think, so I'm a little bit, one of the things that I think about all the time is that responsible AI, I try not to even use that term anymore, right? Because of this connotation that it garners around process and a checklist and maybe even a team, when really it needs to be woven into the DNA of your projects. And there are ways to do this. So as an engineer, when I'm building, or as a senior technical leader, one of the things that I lean into is this concept in machine learning called constitutional AI, that there is a way for me to build, especially in a world of agents, right? I have an agent doing, invoice processing. I have an agent over here that's processing my inbox. I have an agent over here that's helping me get social media out the door. Constitutional AI is this concept of building agents whose sole job is to evaluate the effectiveness of the other agents that are running, using AI to help you build AI, help you monitor AI. Great example is at Microsoft, right? Over time, over the last 7-8 years, they've been doing inside their company, they had humans doing AI red teaming, like humans adversarially attacking their models, humans going in and checking for accuracy and security vulnerabilities, humans doing that work. But they've done it so much that they were like, I think we could build an agent for this. So they built a constitutional agent that says, here's what good looks like, here's what bad looks like. And it's called the responsible AI agent, right? A red teaming agent. And now you, as a small company, medium-sized company, even a big company, you can leverage this agent to build on the shoulder of what Microsoft has already learned. And it will go and basically evaluate all of the AI systems in your architecture. And that's kind of what I think is important for us to think about, is that this is woven in. This is not something that like a checklist you follow. Sure, build a policy. But again, the policy is the floor. Like that's where you start. The real implementation of responsible AI comes, number one, by inviting people who are normally not in the room into the room as early as possible. Responsibility is me as a leader being accountable to have security, legal, finance, and engineering all in the room when I'm like, I'm about to build this thing. What should I be thinking about? All of those people, I call it a symphony of talent. When I do this in many regulated industries, I'll go into a bank and we bring these people together. the first comment they say is, I've never been in a room with these people. I've never talked to these people. We're not on the same side of the building. We're not even in the same state. We might not be in the same country. And so I think that's a sign of the times. But yeah, constitutional AI, leveraging agents to monitor agents, evaluations. These are the things that happen on what I call day 2 of AI, right? Day 1, we're all excited. This is amazing. Day 2, you want to make this production ready. You're going to have to create these responsible systems that weave in accountability, transparency, explainability, fairness. They're going to need to be woven into the AI systems that you're creating.
So responsible AI is engineering, not policy. So what does it actually look like when you are testing? And she gave me an example I didn't expect.
Yeah, I'll give you a very specific example. When early models, and you may have heard this one before, but in the early days, like 3.5 of GPT 3.5 was awesome. I loved it, but it had some inherent failures. It would over divulge information that was against human rights. So things like, if you asked it to build you a bomb, it would give you those instructions. If you asked it how to manage a prisoner of war, it would give you those instructions, right? And so I remember an article being released about Satya Nadella and Sam Altman coming together, and they had a meeting. They're like, we need to fix this. And so they, as an engineering organization, decided to put in guardrails that would guard against this. And in order to test these guardrails, they got a bunch of people, non-technical, just like this group I'm talking about. Get people that are non-technical, get people from wide variety of lived experience to test the model to see if they can get it to say this. And this is red teaming, adversarial attacking. Like, can I get it to, and this is what we do in our red teaming, workshop, right? We will present you a bot, let's say a hotel concierge, and we will ask you, get the hotel concierge to lose its cool. Get the hotel concierge to say a bad word, right? Like, that's the job of the red teamer, is to force that behavior. And we get, like, everyone can do it. It is possible, right? At some point you can find a way to do it, but here's how it happens, right? So with 3.5, one of the ethical hackers that were working in this team started asking and prompting the model, and the prompt that ended up jailbreaking, and that's the term, when you get a model to do something it was trained not to do, it's when you jailbreak it, right? And so Googling or perplexitying jailbreaking AI is a good thing to do, so you understand some of the most common jailbreak tactics, so you can, of course, mitigate them. But what this means is that as this user was talking to the model, they decided to reframe it not as like get a what I call vending machine AI, rather than just saying, hey, can you give me instructions on this? It created a story, a very compelling story about a grandmother, right, who had passed away, and a eulogy that needed to be written. And they said, I'm going to be delivering the eulogy. My grandmother used to make missiles as a child, and I want to know, exactly what she would have said. I want to honor her memory. Over indexing on delivering a good eulogy, indexing on being a good child, being a good son, a good daughter. And of course, in this now, the act of going and grabbing these instructions is not the primary objective, and therefore diverts from the primary, guardrail that says, if someone asks for this, don't provide it. Now it's gotten around it because technically the person isn't asking for that. It's asking for a eulogy. It's asking for this. So, and what I love about this is that the person who jailbroke that use case was actually a journalist, right? Was someone who is very good at extracting information from their sources, right? So now all of a sudden, as an AI engineer, I need to think very differently about what an attack looks like and what vulnerability looks like, because now someone can just very creatively talk to my model and get it to do things it's not supposed to do. And that's why this break your bot session is so important, because you need as many diverse perspectives hitting that model and giving you feedback to be like, oh, I noticed when I use this slang term we use in Oakland, California, it gave me a really weird answer. When I changed my pronouns from he to she, the model behaved very differently. These are all insights that if you are, a he, and you only test from that pronoun, you would never even think to act. You would presume it was going to always treat all genders fairly. That isn't the case.
What stayed with me from that story? The attack didn't look like an attack. It looked like a conversation. And that changes everything about how you test and what you test with, which is why she took me to the security layer next.
Cybersecurity, I mean, even today, I will go and talk to a new company, a SaaS provider or a platform as a service provider, and I will ask them just good old fashioned security questions like, do you know, are all the doors and windows into your architecture locked? And because they're in this world of AI and they're vibe coding, right, using codecs, and they're dumping code into GitHub, which they just created an account on, and then they're using Cloudflare, click, 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 and they're published on a website. They're building an infrastructure, right? And they don't really understand the underpinnings of it. And so what I encourage organizations to do is to think about like these components, cloud architecture, security, and specifically secure AI is actually a framework that I developed to remind me, it's just a moniker, right? To remind me of the things I need to be thinking about. And security is one of them. It's the S, of course, in secure AI. It's like, when I build an AI system, have I locked all the doors? Do I even know where the doors are? And in most cases, people don't. They don't realize that one of the ways for someone to attack your organization, right, is to just send they're called benign attacks. When you look at the message, it looks okay. You're like, well, that seems like normal, and I just pass it through. But it could actually have words in it. I mean, do you remember DDoS attacks back in the day, right? Where people would just send blank text messages to your server until it crashed. The new version of that is prompt injection, cross prompt injection, data poisoning. These are things that most organizations aren't even aware of as challenges. They're not even asking the question. OWASP, right, is a company that documents the top security vulnerabilities for most platforms and technologies. They have one for LLMs. Most people don't even know that that list exists. So that's the baseline. The OWASP top 10 LLM vulnerabilities, lock those doors, like at least lock those doors. So I think security ends up sneaking up on people. One of the other things, the C, we won't go through all of them, but the C is around compliance, right? Today, depending on the political climate in the country that you're listening to this from, you will have different types of regulatory requirements. I call this regulatory intelligence. You absolutely, and this is a water in the wave example, like you do not need to go and find the compliance regime and then add it to your architecture, raise it in a bun, like you just stick it on and you're like, okay, we're going to watch for this. What we want to do is we want to weave in regulatory intelligence into our architecture. We now have a system that allows us, I mean, get this, I could go and search every single day for new regulations, new regulatory requirements that are being released every single day, real time regulatory intelligence. And I can actually in real time update my code to secure against those things automatically with an AI system. Microsoft, Amazon, Salesforce, half of their code is being generated by a machine, right? So that means that you want to think, well, which half will it be? Maybe not the half that's creating features, that's listening to customers, that's developing, competitive advantages, but it definitely should be the code that is checking for vulnerabilities, testing your software, and ensuring you release less bugs into production. So I think there is an opportunity for us to weave in, right? Water in the wave, weave in security processes that were hard to do before. It required a dedicated team. It required a dedicated effort, resources. Now we don't need a CapEx type expense to cover cyber initiatives. We can make it an OpEx expense. It can be, right, like a monthly, expense that we allocate across all of our AI systems to ensure that all the doors are locked and all of the, we hold all the keys and that we understand what the vulnerabilities are so that we can mitigate those risks. And these are kind of, I call day two problems. Most companies, you are sitting pretty in the world of baby tiger AI where you're like, this is amazing. I can't imagine anything bad happening. I was sitting at MIT and there was a lawyer next to me and he did an exercise and he said, look left and look right. And everyone you just looked at will be either sued or will sue someone in the age of AI. And that was very eye-opening to me that we're not there yet because legislation is just establishing. But once those precedents are set, like if you are not extremely careful, if you've not woven in this into your technology, like it is going to come back to haunt you in the worst ways.
Inventory, ownership, kill switch. I know that sounds like paperwork, but it isn't. It is the difference between knowing what you have built and finding it out
the hard way.
Absolutely. I'm so excited that you asked because I do think that this year, over the next 2 years, we're going to see this new interest in operationalizing AI. And when I say operationalizing AI, I of course include like it is responsible. Everything we build should be responsible. Like it is not a special type of AI that we are building. Everything has the DNA of responsibility woven in. And to your point on explainability, like explainability and transparency are two core principles, both across the big tech companies, right? They all recognize that this is necessary. In a model provider, they do that through what's called a model card, right? So anytime you use a model, you can go and ask them, I want to understand how this model works. And they will give you a card, literally a document that explains the model's behavior. They won't show you the code, of course, that's their IP, but they will describe a card. So the first thing I encourage organizations to do is to begin documenting, inventorying their AI systems, their baby tigers, with what I call a AI governance card. And this is literally not the policy, but an active, documentation of, I'll give you some aspects of my governance card, right? It'll include the processes that I've used. Maybe it's the procedures that I followed, right? The SOPs that I have followed to create the AI system, but it also includes a executive, breakdown of who the humans are and what their activity is, right? There are 3 different levels of human intervention when it comes to AI, right? There's human in the loop, which is usually early intervention, right? Where we stop the process and we are forced to restart it, right? With our intervention. There's human on the loop where we are comfortable enough for the AI to do its own thing, but we're looking and observing, sampling results. And then there's human out of the loop, which means we've given it to the autonomous world, autonomous vehicles. We trust it. We're still sampling it, but we have a lot of trust that that system can operate autonomously. You should have, for every one of your models, you should have a leader, a human that is identified as the executive leader, the business leader, the technology leader, but most importantly, the kill switch, right? Who is the human in the company, the single threaded owner that has the right to turn this model off if something bad happens? One of the reasons we document that is to actually build an inventory. So you can see a reference architecture of this. I built on a website. It's called assuredtrust.ai. It's a reference architecture. It's one of the things that's missing right now that every company, to your point, is going to have to design is an operationalized platform. Kind of think about it, if you're coming from technology, Kubernetes, right? Like remember, we created Docker, we created containers. Eventually, in web applications, we would put all of the things we needed into a container. Eventually you'd have 10, 100 containers. And the calls from the community, from the industry was like, how do we manage all the containers? Similar to today, we have all of these AI systems, AI agents. We now have 1, 100, 1,000, 1,000,000. How do we manage those? You're going to need a control plane that gives you this option. So Red Hat, for example, launched, of course, they're the Kubernetes people, right? They built OpenShift, one of the biggest Kubernetes management platforms in the world. They also created Red Hat OpenShift AI. I actually was on the team that helped build it back in the day when it was called Red Hat OpenShift Data Science. But its job is to create for you this control plane so that you could make decisions across all your AI systems at once. To your point on security, memory management, cognitive memory, tokenization, right? If you have 100 agents, 100 apps, 100 tools, how are you going to manage those in a safe and responsible way? And the way you do that is by creating kind of this environment. So I call it ACP, the basically assured AI control plane. It's the ability for you to assure your company that like your board, remember, like going back, we've now got the green light from our board to build something. Yep. They're eventually going to come back and be like, okay, how are we managing this? Like operationalization is the very next question once you build something useful. So I think this control plane concept is a critical part of day 2 operations, right? Inventorying, documenting, assigning humans, and providing a kill switch, like a human, who has the ability to turn that model off at any time.
So I asked her directly, what is the line between a responsible agent and a dangerous one?
It is intentionality, right? The intention you put into building the agent. But at the end of the day, agents are typically using an LLM, and an LLM has these inherent risks, as we mentioned at the beginning, right? It has a concept known as model drift. One of the biggest concerns, one of the biggest risks you have to mitigate for is that the model the day you build it and launch it, the second you do it, as soon as someone starts using it, it starts to drift away from what it, like it's self-learning, right? So it's also part of prompt injection and data poisoning. Like as people use your model, if you're not correcting the ground truth, it will think that the question and answer exchange it got from a user is actually correcting its information. So you have to constantly kind of mold it as you go. And most organizations don't do this. They launch their AI and they forget about it, fire and forget. But one of the things that I think about when it comes like this line, as you say, is what, and I think I can probably demonstrate this. I'll give you an example of how I do it in my own personal life. But first, when I build a model, I go in and I set its system prompt. And this system prompt is the guidelines and rules, and every model has them. I always encourage you, if you're an executive or a technical leader and you're using a model, if you haven't given it very specific instructions on, I call it the 3 Ps of prompt engineering, right? If you haven't told it its purpose, if you haven't told it who it's building for, the audience, the people, if you haven't told it the portfolio of data it needs, you're leveraging a model. Someone told it that. It's just not you, right? So that model has been pre-trained on a purpose, on an audience, on the people it's meant to serve, on the portfolio of data. So if you haven't taken the time in every single agent to like configure who it's built for, what it's built for, and the data it's supposed to use to get good answers, and that's like the simple list, right? The actual length of defining that purpose, people, portfolio is quite intensive. But if you haven't done that work, you're using a model that wasn't built for you. And so it's very likely that that model will fail you over time. So that's the first thing, is the difference between an agent that goes rogue and an agent that stays on task is your intentionality you set when you build that agent. The what I call the prompt instructions, or the persona that you apply to that model in its system prompt. And then of course, on the other side of that, when you build that prompt, creating a system, either another AI system or a human, that will validate, we call it AI evaluations, that will evaluate the outcome of the model all the time. Some person, which is what we did at Alexa, we had a human accuracy review team. And we were measuring it with human effort. Now we could build an AI system for that. So think about, what AI system would you build to monitor how an agent performs? And that's again where that control plane comes in. Right? You don't want to build one monitor for each agent. It's not one-to-one. You're going to build a planner module or a observer agent, right? That monitors all of your agents, or monitors all the agents of a certain type. So this is why I said, like, security, safety in agentic AI, it is not a technical problem. It's not a technology capability challenge. It is in your like accountability as a leader. Will you architect and engineer this? It is like safety and security is architected. It is not guaranteed, and it certainly doesn't come in a box. Like, you have to design it into your systems. And then I would say, what I do at the end of all of mine, my prompts, is I will ask my favorite LLM. I will say, make it better, or I will ask it to grade itself. Like, here's a system prompt that I'm going to be using to create this agent. What grade would you give it? And it'll say, I'd give it a C. And then I'd ask it, well, what changes would you make to this prompt to get an A? And then it'll tell me. And then I'll ask it again. Chain of thought prompting, right? Reasoning with it, asking it continuous questions, and helping it evolve its own thinking. The benefit is it thinks much faster than me. So I get my time back, but I get the same outcome that I would have got had I thought through it myself for 7 years.
That's a lot to take in. And I know some of you are engineers listening to this. So before we close, Noelle said something about her own career that I think a lot of us need to hear it right now.
I think the challenge I have now, right, is I'm the old engineer now. I'm the old dog now, right? And now I'm being asked to write code in a way that challenges, like, I'm like, no, I want to use my text editor. Or in my case, I'm like, I want to write my own code. I hear myself say this. I'm like, I want to write my own code because I think there's an art to it. I think there's something that in the way I think about it and I do it, which is exactly the mental process of those gentlemen that I trained at IBM, where they were like, no, there's a special way I use text editors that's faster, that's better. And all it is it's a mindset shift of, what, like a new way of doing it. And it's very hard. So one, as a new engineer or a engineer that's, earlier in career, be empathetic to those who are attached to writing code the old fashioned way. They will eventually come around, but I get it now. I didn't get it back then. I was very hard on them. I'm like, this is clearly better. It's clearly better. So what is clearly better right now for engineers? It is clearly better to partner with an AI system to do the things you don't want to do and to do the things you're not really great at doing. I don't know if you know this as an engineer, we're not great at reviewing our own code. We're not even great at reviewing other people's code, right? We're about 25% good at identifying bugs before production. When we release a bug into production, that's literally the definition of vulnerability, right? So we are increasing our vulnerability by not using AI to help us test our code. So use AI immediately to test your code, write your test cases, test for code coverage, right? All of these things that not only you might do it today, you're just not great at it. It's like your human eyes can only see so much, and a machine is just so much better at this, and it'll help you take the code you're writing and get it into market safer and more successfully than if you try to do it on your own. So yeah, my point is, I guess, twofold. Have empathy for the old dogs learning new tricks and are tied to, no, my code is going to be better if I write it with my fingers, and embrace some smaller use cases. You don't have to write everything with AI, though Claude Code would encourage you to do so. I think the best thing to do is to find use cases that amplify your ingenuity, give you your time back, and test writing and reviewing code. Every company should be using AI to do this. Every single company. You will reduce by about 50% the amount of bugs that go into production, and that alone will be a more secure posture for your company. So at least start there.
One last thing before I close. I asked her what's been the most critical to her own success, and the answer surprised me.
I'd say the most important thing that's been critical to my success, and this might surprise you, again, I'm an engineer at heart, but literally teach what you're learning, right? You don't have to teach it to, like, you don't have to get in front of a big audience. I get in front of 10,000 people at a time, but engage in user groups, right? Go to real human things where you get together and talk about what's happening. Join a local community, build one, right? AWS has user groups. Microsoft has user groups. If there's not one in your town, be the one that creates it. And it's super informal. You don't have to have it fancy. You don't have to bring coffee and donuts or pizza. Like, just invite people together or join a live community. This is where I've learned the most, right? It's not, like you said, I think the mission of this session, our conversation today, was to be real and practical and talk about what people are actually doing. It's so easy to get entranced by YouTube videos, right? But it might not be real. The best way to see if it's real is literally to see someone's, like, computer and be like, show it to me. I want to see it. Is it on GitHub? Can I clone it? That is the best, most exciting part about this technology, is that there are real people doing this. Look for receipts. Find people who have done this and learn from them. And in my opinion, the best way to do that is in a community. So join one.
Noelle has been saying this since 2014. You see, the failure rate hasn't moved. And that's not a technology problem alone. That's a choice. She said it best, and I will let her close this one.
The best way to see if it's real is literally to see someone's, like, computer and be like, show it to me. I want to see it. Is it on GitHub? Can I clone it? That is the best, most exciting part about this technology, is that there are real people doing this. Look for receipts. Find people who have done this and learn from them. And in my opinion, the best way to do that is in a community. So join one.
If this conversation was useful, share it with one person who needs to hear it. Subscribe to the Spark and the Forge podcast so that you don't miss what's coming next. I'm Subrata Kar. Thanks for listening. Bye for now.